S and T are points on the circumference of the circle, which has centre O. P to T is tangent to the circle, and SOP is a straight line. Angle OPT is 32 degrees. Use this information, we need to work out the size of the angle marked X, and we must give a reason for each stage of our working. Okay, so questions like these can look quite daunting at the start because there's a lot going on. However, normally once you found the first bit of information, then the next bit will follow, and the next bit will follow, so it all follows on quite logically. So the hardest part is finding the first bit of information. So we're going to have a look at what we've got. So we've got a circle here, and we've got a triangle here, and then we've got another triangle here. So we've got some triangles going on. We've been given this angle here of 32 degrees. However, there's another angle we can find out quickly, and that is OTP here. It looks like, look at the diagram, that it's 90 degrees. Well, we want to check that just to be sure. So in the question it says PT is tangent to the circle. We also know, because this is the centre of the circle, this line here must be the radius. And whenever we've got a tangent and a radius meeting like this, we know that it must be 90 degrees. So we've proven that there, and I'm going to draw in this symbol to represent on the diagram that's 90 degrees. Also says we need to give a reason for each stage of our working, so I'm just going to write something down here. So essentially what we use here is one of our circle theorems, and I've written this down here just to summarise it, saying the tangents and radius always meet at 90 degrees. And because we've got that here, this means that the angle PTO is definitely 90 degrees. Okay, cool, so we've got our first bit of information, now the rest can follow on. So something else that we know is that the interior angles of a triangle add to 180 degrees. And we've got quite a few triangles up here. The one I'm going to look at is here, so we've got TOP, this triangle here. And we've got two of the angles, we've got 32 degrees here and 90 degrees here. And because we know all of the angles will add to 180 degrees, we can work out this one here. So from that, okay, so I'm going to say 180. I'm going to subtract from that the angles we know, so minus 32 and minus 90. We're going to see what we get, and we get 58. So that means we know that this angle here is going to have to be 58 because all of these angles added together need to make 180. And I'm going to draw that onto the diagram here as well, so remember it. So here we've got 58 degrees. Cool, so we've got another bit of information. Now I'm going to have a look again. So I'm going to focus around here. We know that angles at a point on a straight line, so here, add up to 180 degrees. So all of this is 180 degrees. And because we've got this part here, we can work out what this angle is here. So again, I've written that here, giving our reasoning like it asked us to do. So angles at a point on a straight line add to 180 degrees. So we're going to do 180, subtracting what we know, which is the 58, gives us 122. So angle is 122 degrees. And again, I'm going to draw that on the diagram so I remember. So this angle here is 122 degrees. So hopefully you can see how we'll work our way through it with each bit of information leading on to the next step. Now I'm going to focus in on this triangle here. And we see that O to T here and O to S are both the radius of the circle, because again, O is the centre. So we know that O to T and O to S must be the same length. So therefore we've got an isosceles triangle here, because an isosceles triangle is a triangle with two sides of exactly the same length. So I've written that here, that OS and OT are both the radius, so are the same length, meaning that this triangle here must be isosceles. Now I'm just going to draw out here an isosceles triangle so we can visualize this. So this is an isosceles triangle because this length and this length are the same. And what we then know about isosceles triangles is that this angle here, I'm going to call it A, and this angle here, I'm also going to call it A because they're both the same. And then we've got another angle here, I'm going to call it B, which is a different size. So we know that these two angles are the same. So applying that up to the diagram we've got here, because these two sides are the same length, we've got this angle of X here, we know that this angle here is also going to be X. So therefore angle TSO is X. So essentially this is what we've got now. I'm going to draw it out. So we've got this angle being X, this angle being X, and this angle we know is 122 degrees because we worked that out in our previous step. Now this is great, we've got all the information we need to work out what X is, because interior angles of a triangle add to 180 degrees. So we know that X plus 122, which we got in this case here, is 180 degrees. Now we've got an equation we can solve. So combining these x's together, we're going to have 2x plus 122 equals 180. Subtracting 122 from both sides, we get that 2x equals 58. And dividing both sides by 2, we get x by itself equals 29. And we're going to put our little degrees there and remember that. So our answer to the question is that x equals 29 degrees. So we got our first mark by working out that this angle here is 90 degrees. We got our second mark here for working out this angle is 58 degrees. And we get our third mark for actually working out what x is. So going through all the working and getting down to x being 29 degrees. And then we got our fourth mark for our reasoning. So all of this that we've written down, all our thoughts throughout the question, we get a mark for that.